what I want to do over the next 30 minutes is to very quickly, we're going to all grab a seat here, is to very quickly get into industry specifics about what it's really like collecting, processing data, and where some of the bottlenecks are and where some of the problems are. Before I do, and I'm going to be good about interrupting, keeping everybody on time, moving the conversation. But I got, honestly, just hanging out pre-panel, the conversation doesn't quite stop. So this is going to get interesting. Can we just go down the line, Wei? Starting with you first. I would love it if everybody could not just say where you're working, but let's hear the 90-second elevator pitch. You're in Silicon Valley. Go.
All right. Well, my name is Wei. I'm the COO and head of product for DeepMap. We make high-definition maps and localization service for self-driving cars. How many seconds do I have left?
A lot.
All right.
Sorry.
It's functional safety critical. How about that?
Cool. My name's Tory. I work at Mapbox. Eric, it's a location platform for developers. I've been working on autonomous vehicles for the past 7 years, a couple different places. One little experience at OEM, a little at a tier 1, and most recently at Drive AI. But I joined Mapbox about 3 months ago, and I'm really excited about the power that we just announced today with the Vision SDK to talk about new ways to make location both scalable and fresh.
I'm Chris. I work at Microsoft. I am the lead for the Azure Maps team, and we are focused on location-based services in the Azure cloud, natively integrated, and I roll up into the Internet of Things organization within Microsoft, and so I'm driving the intersection of location and IoT, otherwise known as the location of things.
Hey everyone, I'm Vrajesh Bhavsar. I am based in San Jose, and I look after our ecosystem product and partnerships, and we are really excited to work closely with Mapbox and the partnership with ARM around bringing more machine learning to more developers. I'm very passionate about how machine learning is moving to billions of devices and how it's more accessible across many different market segments. And I believe we are kind of seeing this next wave of computing, and it's great to be part of this discussion where we are really moving into how automotive and many different industries are transforming.
Rajesh, while you're talking there, being in charge of ecosystem, what is that? The diversity of the ecosystem at ARM seems kind of ridiculous. What does this actually break down to? Where are the bundles of people that you're working closest with, and how do you actually work with partners?
Yeah, no, that's a great question, and one of the biggest challenges, and I discuss this with our team every day, which is like, what are the things we say no to? And there are so many things we have to kind of deprioritize, but then we work with kind of selective different things. We look at the stack in the sense of what are the different hardware, software, and services companies that are making an impact for machine learning. And I look at how do we partner with companies where we can bring the power of the ARM machine learning platform to other platforms and bring an impact across many different segments, across multiple different developers, and kind of think about how to make these ecosystem companies work together and let them thrive in themselves, and not be in the way, but be an enabler for the entire stack to basically function on its own.
Yeah, you said hardware and software. At ARM, how big is the company right now? We heard about how many chips are being printed, which is, yeah, that's billion with a B.
Yeah.
This morning. But like, what's your hardware software breakdown, and how does that work with your ecosystem partners?
So that's a great question. We are actually very small. When I joined about 4 years ago, we were hardly 3,000 people. And over the last few years, we have grown quite a bit. We are now about between 5,000 to 6,000 people, something like that. Largely because we have also expanded into cloud services with our IoT security services backed by Embed Cloud. One of the ways we kind of think about is not only we design hardware, but we also have to develop the software that will enable all these different hardware IP blocks. So if you're going to deploy something on CPUs or GPUs or NPUs, we don't expect developers to learn every detail of how the hardware works. So we develop the software abstraction layers and the optimizations so that you can really kind of take advantage of all the horsepower that is available for this flexible, but at the same time, power-efficient platform.
Fascinating. Wei, can we go back? You pitched in 13 seconds, not 90.
Wow.
Seriously, what level of an HD map are you making? Where are you getting the data? Who are your primary customers? Again, I almost want this to keep going back to the thread of who's using the stuff that we're talking about here.
Yep. So at DeepMap, we're developing HD maps specifically for level 4 and the level 5 self-driving cars, or people tend to call them the full autonomous cars as opposed to, for instance, ADAS system. Having said that, our philosophy is that once we actually tackle the hardest problem, we can actually also transfer this knowledge or this technology to be applied to help with the ADAS mapping as well. In terms of our customers, well, self-driving is a very diverse ecosystem at this point. You got the tech companies like Waymo, like NVIDIA was on stage earlier on. A lot of the tech companies or the traditional software companies want to enter this space, including Waymo and Uber and so on. And you also have the classic car makers, the Ford, the GM, the Daimler, the BMW of the world. And you also have the classic T1 supplier or tier 1 suppliers who also want to rebrand themselves sometimes as maybe even a full stack self-driving provider. The example is Delphi branching into Aptiv, for instance, through the acquisition of Nutonomy. So for us as a mapping service provider, we don't really pick which sector we want to work with. We want to support everyone and help them accelerate their path to self-driving.
So each customer, so how does it actually work then? What part of the map is shared across your customer base versus what part of your customers are needing to make their own map or customizations on top of the map?
Right. So it varies a lot, actually, from customer to customer. One thing that we strongly believe in that there's really no such a single map that will serve all the different needs from the different customers. Whether or not it's a classic OEM versus a tech company, I think their needs are very different. And on the just very practical level, let's say take the example of the tech giants between Alphabet or Waymo and Apple. They got to differentiate themselves as well. Or between the Ford and the GM, they got to differentiate themselves as well. So because of this desire to be different from your competitor, they're designing their software stack differently. They're designing their hardware stack differently. I think earlier today there are different sensor makers presenting as well. For us, we want to make sure that some of the fundamental things are shared across different customers. For instance, everyone got to keep track of the lanes, the crosswalks, the traffic lights. Now, how they actually get used by the perception system and by the planning system, that's something that we see at least that varies from one player to another, and that's where we allow our customers to do customization.
And do you see a point where the needs for the map to start becoming more standardized across the OEMs? I mean, knowing the lanes, you would think everybody's perception algorithms are going to start becoming the same. At what point what percentage of the map is ultimately going to be the same versus what's going to be custom? And then why would you ever need custom stuff on top of it?
Well, I think definitely I agree with you. I think over, I don't know what the exact length of like this self-driving development is going to be. It might be 3 years, it might be 5 years, it might be even longer. But I think the general trend is that we will see some standardization over time, particularly as people settle down on hardware choices, particularly when people also start settling down on the kind of the optimal software architecture as well. At this point, I don't think anybody has a winning solution that says, I'm so much better than all the other options out there. But eventually, just like...
But that makes it great for you. Because
Yes,
then everybody's
yeah.
coming to you because we're
Hopefully.
at this moment where
Yeah.
nothing's been decided yet.
Right, and it
Right.
will certainly make our life easier because we don't have to make 100 different copies or 100 different customizations. But my prediction is that this is going to take some time to kind of settle down. It's not as simple as let's just figure out the standard way to map traffic lights, for instance, because the traffic lights eventually have to be consumed by the perception system of the self-driving car. It has to be consumed by the planning horizon of a self-driving car. So all these systems have to have some kind of standardization as well before we can talk about standardizing map, which is kind of the foundation layer of everything else.
Chris, you are also benefiting from this moment where all these OEMs are coming online, or better said, connecting their cars for the very first time, getting massive amounts of data for the very first time, and then trying to figure out what to do with it. What are people doing with the custom data that they're collecting now that they're connected? You said some crazy petabyte stats today, but like, why do people want to collect that much data?
Yeah, right now they're just dumping it into storage and trying to figure out what to do with it. And that's the reality, is there's so much data flowing off of these sensors on vehicles that they know there's value there, but the reality is it's arguably too much data right now to really comprehend. And so what we would like to do at Microsoft is provide the tools that are imperative for making sense of that data. And the impetus for our team is effectively to go after that and start making sense of how does this align to roads? How does this, does this actually create roads? And we've got some forward thinking on that exact point, but it also ties back to your announcement today, right? Like 5 terabytes of data for a test machine a day it's insurmountable, right? Like you can't scale that out.
Yeah.
And over time, over the next few years, you get to 15 petabytes. Like that alone is just, you can't think through that. And so AI on the edge is going to be imperative, but in order to do that, we need the infrastructure to support it.
Well, okay, so say you all have just, what's the current market share in terms of cloud ownership? 13, 14, 16% now?
It's something like that.
Yeah, but that's ridiculous growth.
Yeah.
Do people know what to do? I mean, you're given the infrastructure.
Yep.
Or are they then coming back over to DeepMap and being like, all right, how do we actually make this map? Like who knows what to do with all this connected data and knows the kind of map they need right now? Or is this just total wild, wild west?
Right now, from where I'm sitting, it's wild, wild west. The tool sets really aren't there in the clouds to make sense of geospatial relational data, right? And so, to go back to your earlier question, like what are they doing with the data? What they would like to do with the data is add value to their customers, right? Ultimately, you take someone like Audi who has a very specific customer base. They would love to have additional layers, what we consider layers today, that they would feed back to their own map, to their dealers, as well as to the consumer themselves. And so being able to hit that multi-tier value chain is imperative to them in the future. But it's hard to do right now because the tool sets aren't there.
Yep.
How do you at scale, how do you take 5 terabytes of data and effectively do map matching, right? It's insurmountable right now. And even just the collection and transport, Wei and I were talking in the back room, like the network is a big bottleneck right now. And so do you go and try to transfer this over the wireless network? No,
Yeah.
you take drives and you pull them out of the cars and you stick them into some fiber network,
Yeah.
and you start uploading.
Oh yeah, so this is a great point, and I think this is where a lot of different experiments are going on, and I sort of feel all the data that is already being pushed, even that is not enough because there's already there's so much data out in the physical world that is just impossible to capture everything and push it back out there. We were discussing about this. We kind of think about this as three laws of machine learning at the edge. This is the law of the physics, laws of economics, and law of the land, which is physically, it's just impossible to be shipping whether you have Wi-Fi, whether you have 5G. You can't be shipping so much of data, real-time sensor data that is being generated back to the cloud. So you need to be processing this stuff locally. Economically, there is just so much horsepower needed to process this stuff back in the cloud. So for example, Google machine learning team did some study where they did some study on if Android were to use, all Android phones were to use 2 or 5 minutes of voice commands every day, then they will have to double the size of the data centers. And Google has a lot of data centers. Right? So if you think about the same kind of implication on if automotive maps or drive or what have you are going to start pushing data back to the cloud, you're going to need a lot more infrastructure versus if you can distribute it, if you can bring these capabilities out at the edge, this is where you will be able to get that kind of scale and that kind of robustness, right?
On the subject of scale, sorry, go on.
Oh no, and then lastly was law of the land, which is there are certain places where you are not allowed by government law or different laws where you're just not allowed to process or move all this data across geographies, across boundaries, and things like that.
Yeah, and to put it into numbers, so if you look at the 15 petabytes a day, that's 22,000 processors, both CPU and GPU, running full time for 24 hours.
Staying on the subject of scale, Tory, how often does a map need to be updated? No, seriously. I mean, we're coming.
5 seconds ago.
Yeah, that's a great question. I think we're getting to the point where it's almost a real-time expectation for certain things, for certain use cases. If we're talking about oh crap, the right lane is closed, I need to make a lane change. We've seen that humans can do that in the fly, or if the restaurant you're going to doesn't exist when you get there, you can go to a different restaurant. But humans are really great at dealing with ambiguity and dealing with unexpected situations, but we've been shown, even in very obvious situations where even a teen driver would have known exactly what to do, autonomous vehicles really struggle, whether that's going around a double parked vehicle or knowing that it's safe to make eye contact with someone to scoot ahead of them in a crosswalk. And if there's map data that's part of the system critical stack, that has to be extremely fresh. And an issue we had at my last job, and I think anyone who's worked on an autonomous vehicle can appreciate this in terms of the scale of data. If you really want all that data and then try to figure out later what to do with it, you're going to run into problems really quickly because we'll fill up a 1 terabyte SSD in an hour and a half, and we'll collect so much hour in one afternoon of operation in a familiar area where it's actually faster and cheaper to FedEx those hard drives to another part of the state than it is to put it through the cloud. No, it's crazy. And we're in a really interesting sort of estuary right now where we have the opportunity to use a distributed network of sensors. We don't need to get all of our data from the same place, but there's so much incredible data that we've been familiar with for a long time on the GPS side. This has been around for years. If you look at a map of the road network and see red, yellow, green in terms of the speed flow of traffic, but if you start to add even one other piece of data, like in our case, whether it's vision or if you have some information from IMU or something, that is every bit as meaningful as going from 2D to 3D in terms of adding more context. So a really simple example is if you look at a picture of the 101 and it goes when it goes red and it goes dark red and it just goes black, and you don't know if that's no data or it's don't even try to go somewhere. If you had a piece of context there, I was driving maybe a year ago, and there was an active shooter in the interstate or something like that, and they diverted the entire interstate off of the interstate during rush hour on a Friday evening. If you had one snippet that showed anything what that looked like, you would know, just turn off traffic for that area, tell people not to go there. But it would take hundreds or thousands or tens of thousands of ping points to figure out the same thing if your only sensor is GPS. So adding that piece is extremely valuable.
So you brought up just a vast amount of increasing data as you add more sensors. Where do you process your data? Where are your costs in making the map?
In the cloud.
Is it,
Our cost is the cloud.
Are the majority of your all costs, who pays your costs? Do you bundle those costs in to the OEM? Do you run on the OEM's infrastructure?
That's right.
Is it processing costs? Is it storage costs? Where is it? How is making a map expensive?
Well, I think, on a very, very high level, obviously not all the cost is coming from the cloud, but if you think about the steady state of map creation, it's not about creating new maps, it's about maintaining the existing maps and keeping the maps fresh. The challenge comes from 2 points. One, how do you tell on the edge whether or not you should refresh that map? A double parked car probably is temporary enough that you actually don't want to push an update, versus a broken down car in the middle of the road. Well, you probably want to update that.
Yep.
So one key question is like what decisions that you actually let the edge compute to decide to make a decision on the spot, versus what information you actually want to push to the cloud and ask the cloud to make a decision and maybe even distribute it to more cars.
And you're having to write all that logic now?
We have to write it now. Yes,
So
absolutely.
DeepMap is figuring out
Yeah.
what data to actually send back.
Yes. And to us, we always, we tell this to our customers. Map update is the steady state of map creation. Like you have to treat these two problems as the same problem. Otherwise, you will run into a wall very quickly after you create a map, because you will have a very unscalable, unless you have designed map update into the process, you will have an unscalable problem to solve later on. And then in terms of
Stay on that. Why? Like the map becomes brittle?
the process will become very brittle. It's very hard for one to actually keep the maps up to date because you haven't solved the fundamental problem of how to push incremental updates through the pipeline.
Chris, this sounds like a great way to have recurring revenue.
It
Way's
works.
pitching this always on nonstop mapping platform here.
Yeah.
Seriously, how you all been working with OEMs for forever?
Yep.
Have you actually started? And you shared some numbers that were insanely absurd
Yes.
about how expensive this could be.
Yep.
Have you all started to run cost savings analysis of what it looks like to be operating more intelligently on the edge for OEMs? And is that a certain way to value sell?
While I may not seem incentivized to do that, we've only just begun that process. Yeah, I mean, not only in wanting to save our customers on the costs, but that's really not our business model, right? The business model is about the tech and the learning and advancing artificial intelligence.
Mm-hmm.
And so we want this advancement to happen. We want to push things out to the edge because that's sort of the new Microsoft, right? Yes, Azure is turning out to be kind of a money machine, if you will, but the reality is we have loftier goals around the advancement of artificial intelligence and the benefit of our customer, right? It's not to gouge on price, it's not to gouge on revenue, it's just that's sort of, it's almost as if we're on a journey up a hill right now, and once we get to the top, there will be this next level of advancement where all of the machine learning will have been created, all of the optimizations for storage will have been done, and all of the compute cycles will move out more distributed and probably hybrid. It'll run both in the cloud and on the edge. But the reality is, the advancement of AI will take off some of the workloads, and that's what we are trying to do to help our customers, not just gouge them on price and continue to increase costs for them. So the analysis is really, because the data is so new, it's hard to gauge what the impact will be. I think it's actually a pretty complex equation when you're trying to figure out where you'll be in 2 years when there's so many variables that are continuing to change, advancements in AI, advancements on the edge, advancements in data collection and sensors. So it's a hard thing to predict.
But if you're not sure where you're going to be in 2 years, the tendency is to hold on to as much as possible. So, I mean, how big do these databases ultimately get for some of these OEMs? I mean, are you just making bank right now, charging for massive amounts of data storage?
I am not personally making campaigns, but I think that's reflected in Microsoft's reports quarter to quarter, and but it's bigger than that, right? This is about selling the advantage of Azure as a whole thing. It's not just storage, it's not just compute. It's a value chain of services that are attracting enterprise customers like the OEMs, right? Yes, they're investing deeply in Azure because it's a great place to put their data, but the additional capabilities that Microsoft's adding to Azure actually makes it really enticing to come and be a part of that Azure family. Computer vision, machine learning, IoT, like all of these different facets are natively integrated into our cloud, and because their data storage is there, the data has gravity.
Yeah.
And so it's pulling other capabilities in. Yeah. And so all of these customers that need IoT capabilities like IoT Hub and Edge, they need location-based services. They need computer vision and machine learning capabilities in the cloud because their data is already there. Yep. That's what's making Microsoft really attractive to the OEMs. Is really beyond the costs. This is about the value of the entire picture for Azure.
Tory, you talked about going the equivalent of going from 2D to 3D. Vision SDK ships publicly in September. What do you think that's going to? What do you think some of the main use cases are going to be in terms of customers wanting to build not just apps, but then get the data back out from it?
Thanks, Eric. I'm so glad you asked that question. I've been asked this question a lot of different ways as people have started to play with this, and I sort of see 4 different verticals that are really interesting. First, I think it's probably for professional drivers, because anyone who's, especially if they want to have context, everyone's familiar with the problem of trying to find out where your passenger is, especially if you're having issues with multipath driving down Market Street in San Francisco. So we can actually capture road topologies with just a couple frames of imagery to align the vehicle more closely to where it actually is on the road, even with multipath. And then instead of just looking at a 2D map that's misplaced in terms of your location, you could actually look and just have a giant green arrow pointing at where your passenger is. And on the passenger side, you could have a passenger see the spot on the curb where you're supposed to be illuminated, so both driver and passenger know where to walk to. That's one cool idea. I think also fleets, there's obviously tons of applications in terms of wanting to do asset tracking, but also wanting to know like where's the front of the building I need to walk to, or an enormous building that has 5 or 6 entry points, and you have to try to figure out where that package is supposed to go, because that's an experience that can come with you out of the car if you have to walk somewhere as well. Then the insurance space has a lot of really interesting applications. One of our friends, Nado, is here today. They have all sorts of things that they've been able to do with vision for improving driver safety as well as asset tracking. And then finally, I think another emerging area is smart cities. If you imagine even getting beyond putting this inside of a smartphone, if you just have any connected camera with any kind of commute connected to it, the kinds of information you could glean for maybe if they could improve the streets in San Francisco so the dash cam footage isn't so bouncy, that would be awesome. I would pay for those cameras. But there's a ton of applications also to keep up with, like if you want to track like pedestrian density to figure out where to put new crosswalks. The really interesting thing here that I think is sort of an overarching theme in the location space is the nature of mapping is changing in terms of how we use them. Especially we're talking about anything mobility related where safety is even part of the conversation. And it is that anyone that has started to make a map is never going to finish. Because if you stop, it's now a historical map. Because that data changes so quickly. If you want that map to continue to be used, it's crucial that you have sources of continuing to improve it without needing to call up a surveyor to do it for you every time. So it's really important to build and leverage more of these sensors, and then have a way of collecting that data and keeping it fresh. And to the question we were talking about earlier, just my 2 cents, in terms of knowing what to do with the data, I think one great advantage that we have is incredible developers that we work with, that they don't ask us what data do I need, because they tell us what data they need, and they've done some really cool stuff that we're super excited to show today.
That's that's very similar to what you were saying too.
Yes.
It's just like this process is never going to stop.
Yes.
Real quick to wrap up, prediction. Come December, what do you think the craziest stuff we're going to see between now and December, either with your company or in the space?
In self-driving space,
Mm-hmm.
I think we will see actually quite a few about self-driving, not about our mapping. I think people will see number one, some cities will actually be some governments, I should say, be very proactive in putting out, let's say, routes or regions that are dedicated for self-driving. We're seeing that trend in some Asian cities already. And then two, I think you will see quite a few new self-driving fleets that are actually operational, like we already have a few today, but I think we're going to see, let's say, a big increase in number of these fleet operations for the
The
next 6
government
months.
angle is interesting there. I mean, Vrajesh, you were also saying, law of the land. Bring us home. What's your prediction on the hardware side? You just heard Wei's prediction on the self-driving space side. What are you thinking about between now and the end of the year?
No, I think that we'll see more and more deployments of real perception models and like something like Vision SDK or other systems that will be deployed on existing CPUs and GPUs that are like deployed at scale and not be a niche thing anymore.
Cool. Well, let's stop there. Thank you all for taking the time and coming out today. Everybody's going to be here tonight for drinks, so I hope everybody in the audience gets to come up either after this session or tonight, so we can kind of continue this conversation. I hope everybody is getting a sense of just how early it is in the space and how much more there is to still build. And I think being together like this allows us to talk about these unknowns and start building our own strategy. So I just really like the different backgrounds that folks are bringing to this conversation up here, and I look forward to extending it over the next 2 days. Hey, thank you so much. Cheers.